All right, so today we have a speaker with us that's going to present a little bit about actuaries, kind of what they do, his experiences, how to become an actuary. We'll look at a few kind of problems that might seem a little like intuitive at first, like, oh yeah, the answer would just be this, but then when you look at it a little closer and think about it, you know, the numbers, it's a little surprising sometimes, the results that you get. So I won't say anything more, and I'll turn it over to Jonathan, who's going to talk to us about being an actuary.
All right. So I'm Jonathan Mark. I'm an actuary at Milliman IntelliScript in the Milwaukee area. I'm originally from Massachusetts, and currently I'm in a graduate program at UW-Madison, which is the State University of Wisconsin. So let's get started. So today we'll be talking about the actuarial profession, characteristics of actuaries, how to become an actuary, and then we'll do some math problems at the end. They likely will be easier than your final. So no guarantees. I haven't seen the final, so they're a lot more fun than the final regardless. So before we get started, have any of you heard the terms actuary, actuarial analyst, things like that? All right, cool. Would anyone like to give their idea of a definition? Nothing wrong with getting it wrong. Just call it out. Go for it. Sure.
I believe you guys use statistics for like businesses and companies.
That's a really good way of putting it. Yeah. So these are a few of the actuaries that go to school at UW-Madison. The gentleman on the right finished our program. The other three of us have 1 more year to go. So we'll answer the question as what actuaries are. First, we'll just touch back to math-related professions. Quick show of hands, how many of you think you'll go into a career that uses math? Any of these, as well as the physical science? All right, so like half of you. Great. Math teachers obviously use math. Engineers, most of the work that engineers do is heavily math-related. Computer system, anyone working with computers often has background in mathematics. A lot of the same problem solvings and analytical skills show up. Economics and statistics, again, two math-related fields. So what is an actuary? The definition, working definition we can go with is a business professional with strong quantitative skills. So like you're saying, yeah, you work for a company, you manage things with numbers. Oftentimes, like the second bullet point says, managing financial risks. You'll end up working with the risk of something happening and ascribing a value to that. And then we often use historical information and mathematical modeling to determine what we think future values of things are. And then it's a professional organization, professional position, similar to how lawyers have to take a bar exam, doctors have to go to medical school, actuaries have to go through what's known as the exam battery of the Society of Actuaries. There are 5 exams that you take in order to become an associate, and then a further 3 in order to become a fellow. So currently, anyone who's in the process of taking those first 5 exams is known as an actuarial candidate, and then they become an associate in the Society of Actuaries and a fellow. So myself, the other 3 classmates I've shown you were candidates in the Society of Actuaries. There are a few different areas that actuaries will work in. Property and casualty rather, is one of the big ones. That's your auto insurance, your home insurance, your fire insurance. Life and health is another big area. Tend to be life insurance companies like Allianz, things like that. They sell, like AIG is another one, State Farm's another one. They sell to individuals who are looking for, upon their death, estate planning and paying for their funeral, and then if they have dependents, a way of providing for them when they're not there. And then health insurance is a big one currently with the ACA and HCA. That's been a lot of discussion in the industry. Basically how to provide health benefits for people, pharmaceutical, hospital, doctor benefits to people, how to price that. Oftentimes people get health insurance through their employers, but only about 53% of people, I believe, work for companies that are required to offer health insurance. So finding a way to cover everyone's a big hot question in the health insurance industry. So, and then pension used to be a bigger field. A lot of pensions have been phased out, but the process of seeing how much someone has to pay into their pension when they retire to the time they die, pulling money out for their regular pension benefits. How that works is a big question, something that pension actuaries will work on. Some places that actuaries will work, often insurance companies, consulting firms, governments, and then other areas such as investment banking, some work in real estate pricing, things like that. Currently, I work for a consulting firm. What we do is we sell to life and health companies a service where we take pharmaceutical data from a list of people looking to buy life or health insurance, use that to associate it to medical diseases from those prescriptions, and then use that to adjust on how much, where one is the average cost of life insurance or health insurance, how much above or below that. So if you have a score of 2, that means you are twice as expensive as a score of 1. If you have a score of a half, you're half as expensive as a score of 1. So that policy might be, for life insurance, maybe $45 a day. If you have a score of 2, it would be 90. Score of a half, it'd be 22. Or I said a day, likely $45 a month. It'd be 90 a month or 22 and a half a month. So some of the skills that people look for in actuaries, that people going to the profession trying to develop, are analytical and problem solving skills. So being able to look at a data set and saying, this is the approach I'm going to take, this is what I'm doing, this is the model I'm going to use, this is the reason why I'm using this model, things like that. Computer skills are important. Recently there's been a push towards using data modeling and big data in actuarial science. Currently there's a big rush to get into this programming language known as R, which is a statistical software that's often used to analyze not just actuarial data, it's used in psychology, it's used in engineering, it's used in economics, it's used in a whole bunch of different fields. Actuaries tend to be people with strong business skills, the ability to communicate effectively, to reach out to other people, to manage their time well, things like that. And oftentimes, if actuaries are working in a customer-facing role, a sales-facing role, they tend to have good interpersonal skills, as well as the ability to explain information to non-technical people, to, say, a hospital director who's working in health insurance, explaining to that person things that they can understand from their medical background that someone with an actuarial background might not see exactly eye to eye on because they have 2 different backgrounds. So being able to explain things like that is really important. And then this is just an exercise. So what variables do you think are predictive for pricing insurance? So the 2 examples up here are different drivers in different cars. What about different drivers in different cars do you think might affect the price of auto insurance? Sure.
Your age.
Your age, that's a big one. Anyone else?
Your driving history.
Driving history, yeah. So if you get in a lot of car crashes, you probably don't want to, someone doesn't want to sell you auto insurance. Anyone else?
How new the car is.
Yeah, the age of the car.
That's what I was going to say.
Sure, yeah.
How fast the car is.
How fast the car is, okay. So, can you elaborate on that? Do you have any thought?
My friend has a WRX and he has to pay more for insurance because it's faster and more likely.
Okay,
car.
yeah. So if he was driving a Honda Civic, he'd likely save a bunch of money. Yeah. Right. Yeah, those are good. So we get into age, sex, driving record, credit report, grades, residence, and then aspects of the vehicle we talked about, age, value, make and model. So as far as the driver goes, the first 3 are pretty self-explanatory. Younger people tend to be more aggressive drivers, get in more crashes, drive more. Men tend to get into fewer accidents, but the accidents they do get into tend to be higher dollar value. And the person's driving record, if you get in 1 accident, you're more likely to get in the second. Your credit history is where it starts getting a little interesting. People have better credit, meaning they're more financially responsible. tend to also be more responsible on the road. It's not a causation, it's just a correlation. So being good with your credit doesn't necessarily mean you're going to be a better driver. Like, it's not the cause of it, but it's a correlation. And then grades, people who are better academically tend to be safer drivers. So much so that a lot of insurance companies actually started offering benefits to, or incentives to parents who have children who start driving at age 16, age 17, and they're performing well academically in high school and college. So that's something to look out for as you start driving. And then your residence, which is where you're living. It's more expensive to own a car in Lowell, Massachusetts than it is in, say, Ashby. Like, a bigger city has more likelihood of someone crashing into you, you crashing into something else, your car getting stolen, things like that, than a small suburban or rural town. So it's an actuary's job to identify all of these. Likely this entire process would be done by a team of actuaries, and they'd have some historical data, some predictive modeling, some saying, hey, like, electric cars seem to be safer, they seem to be lighter weight, maybe we should incorporate that into our pricing model. So you end up with a lot of different sources of where you're getting your information from, and you use that to make one decision that helps price you out based on all these variables and probably some other ones. These are just some other tasks that an actuary would likely do. It's unlikely that the same actuary would be doing all of these. As mentioned before, there are plenty of different practices. So, like myself, I'm a consulting health actuary. So I work for a consulting firm. As mentioned before, going from prescription data to pricing health and life insurance. I likely would not be working on pricing hurricane insurance because that's a property and casualty role. So someone from property and casualty who works specifically for a property and casualty insurance company would likely be doing that. Designing pricing health insurance programs, that's something that a health actuary is likely to do. It's likely not going to be a health actuary like myself or any of my colleagues. They're probably going to be working for the insurance company itself. And then a consulting actuary who's working in what's known as mergers and acquisitions is likely going to be doing the next task of evaluating price and potential risks of a business acquisition. So when a company acquires another company, there's a team of actuaries who work on, like, this is the current cash flow. Do you think it's going to stay the same? Do you think it's going to increase? Are expenses going to go up? If one company acquires a smaller company that has, and they have two different ways of doing business, there's likely going to be a drop in productivity of the smaller business as they learn the business ways of the bigger business. So actuaries look into all of these things. And then a life insurance actuary is likely going to be pricing and designing life insurance. This is just a picture of a giraffe skeleton from UW-Madison. Should you decide to apply or attend UW-Madison, you'll get to see it. It's in one of our science buildings. It doesn't really have anything to do with actuarial science. So actuaries can work in different areas within a company as an actuary. It's not like there's just a bank of actuaries and we all get assigned the same work. We specialize within our roles. So there are financial reporting actuaries who work in accounting, financial analyst actuaries who work for investment areas. Oftentimes actuarial companies will do what's known as hedging or investing in stocks, bonds, things like that, to supplement their company's revenue source. It helps diversify where they're getting their money from. So they aren't just selling life insurance, but they're investing some of that money in other companies, in bonds. They're buying financial derivatives, things like that. So oftentimes actuaries will work in investment. Sales, if actuaries are working for consulting firms, they'll be selling products to clients, to other customers, things like that. There are actuaries who make it to the executive level, so the CEO, CFO, board members, things like that. If you've been in the profession for a while and you're adding value to your company, and the promotion path just leads you to the top, so be it. There are plenty of people who are content with saying in the actuarial department, there's a position known as chief actuary across most insurance companies, which is generally the highest position for an actuary in the company. There are plenty that make it to the CEO, CFO level, but chief actuary is generally the person in charge of actuarial decisions at a company-wide level. And then there are consultants who work within life and health and property casualty organizations who have a specialized area that they can work in, that they aren't working for a consulting firm, but they're specializing in one particular task, and oftentimes they'll be seen as an expert for other actuaries in their practice to go to. And then some work in product development as project managers. So as they're selling a financial product, some of the actuaries work on developing that product, optimizing it, making it customer friendly. So you wouldn't ever get told your rate on a car loan in terms of the quarterly actual insurance rate. It's known as, you're often given the APR, which isn't, that's an annual effective interest rate as opposed to an actual interest rate. And it's just easier for the customer to understand. They're very close to each other, but it actually comes down to the actual interest rate is slightly higher because of how compounding numbers works. And we can look at that at the end if we have time. But sorry for that tangent, but there's plenty of different roles for actuaries to work in. And you don't specifically have to stick to one. It's very unlikely that I'll continue working as a consulting actuary or a health consulting actuary for my entire career. I likely would go into some of these other positions as well as maybe get out of consulting into health insurance if my career is headed in that direction. So all of these skills are really important. It comes down to what area you're really interested in, whether you like working with computers, people, like doing more business or mathematics, or working in teams or working individually. You have the freedom to choose a position that goes across these skill sets. They aren't mutually exclusive. There are some people who work a lot with people and with computers. But for the most part, as you get higher in your position, you'll be working more with people, more in business, and more working working in teams, rather. And then we'll talk about why someone might want to become an actuary. So the work is challenging but fulfilling. It's definitely not an easy job. It's often, you're working with a lot of other people and you're being asked to do a lot of things, and a lot of the times at work I'll say, well, that sounds really hard. And it's like, there's a reason why I'm being asked to do it, because if it was easy, anyone could do it. So the problems that you'll be solving are, as said here, analytical, technical, and creative. You have to come up with lots of different ways of doing the same thing and finding what's the best. Actuaries tend to really enjoy their job. Part of that is many people who start out in actuarial science and realize it isn't for them. They leave and they have happy careers in other fields, sometimes related, like the financial industries. Some people go on to become financial advisors. Some people go into banking and they're quite happy in other careers. Some people become data scientists. But in general, people who stick with actuarial science really like it. And then there's a really big team atmosphere working as an actuary. A lot of the times you'll be working with a lot of other people from other departments. So working together is a really big part of the job. So there is a high demand for actuaries. Currently there are more actuarial positions open than there are actuaries to fill them. So it's a good career to get into, there's good growth. After attending a four-year university with a career in a major in actuarial science, you likely will have job offers right out of college. You don't necessarily have to go to school for actuarial science. I actually majored in mathematics and chemical engineering when I was in college, and a few years later got into actuarial science. It wasn't my first career. I worked in engineering for a bit beforehand. And then, as mentioned before, Actuaries can make it to the executive level of a company, board members, CEO, CFO, consultant, partner. And then CareerCast did a study of the top careers. Actuaries were the highest in 2015. Generally, they tend to be up there. There are plenty of careers that involve mathematics and statistics, quite up there. Mathematician, statistician, and biomedical engineer were third, fourth, and fifth. It's a good area to get into. Basically, having strong mathematical skills is a good way to prepare yourself for any career. But in general, actuaries are pretty content with the work they're doing. As you can see here, it's a growing profession. The number of current open positions is fairly low. There are reasons why the job market's opening up. There are more pushes for big data solutions in actuarial science, which leads to more actuaries entering the profession, and the workload among actuaries increasing. So one way to offset that is to have more actuaries working. As well as the ACA and AHCA have been contributing towards the amount of work that there is for health insurance actuaries. Starting salary is quite high relative to other positions. Starting salary isn't everything. There are plenty of things to consider when you're looking for your first job out of college. Excuse me. But actuaries tend to pay well. They tend to do fairly well financially. By the time someone becomes an associate in the Society of Actuaries, which is the governing body of actuaries, they're likely to make around $100,000 a year. That's fairly competitive among actuaries today. And then let's talk about how someone goes through the process of becoming an actuary. So, how many of you are planning on taking AP Calculus? All right. And how many of you are planning on taking AP Statistics? All right. I'd highly recommend you take both of those classes. When I was in high school, I took AP Statistics, and I wasn't very good at algebra and calculus, so I didn't make it to AP Calc. And then I was told that you don't offer AP Psychology here, but so be it. The more classes you can take in college, the more college level classes you can get credit for in high school, the fewer you have to take in college. So I'd highly recommend all of you take as many AP classes as you can with confidence that you can pass. And that'll give you some more time to focus on your later studies. And then how many of you have heard of the Elizabeth Hastings competition? That's a Fitchburg State math field trip. Yeah, I'd highly recommend you go to that. It's a lot of fun. You take a math exam for 3 hours in the morning, and then when you're done, you kind of just have the rest of the day off. You get to find out how you did in the afternoon, and then that's pretty much it. It's a good time. It's over at Fitchburg State, so it's pretty close to here. Taking that competition and taking those AP exams really shows colleges that you might be interested in going in, that you're serious about mathematics, you're serious about your career, you're ambitious, you're invested, and that'll look really good when you are applying for college. And then branching off of that, try and take computer science classes if you can. Having good skills with computers is useful whatever career you're going into. I'd highly recommend learning things like R, as I mentioned before, SQL, picking up Java, C++, C#, things like that. Just give yourself a familiarity with it, so if you ever get asked to do it day one on a job, you won't be completely lost. You'll be able to figure out your way around, and then if you have to ask questions, asking the right questions is really important, and having that familiarity will help you ask those correct questions. And then choosing a college or university to help you fulfill your career goals, whether that be in actuarial science or something else, that's really important. As mentioned before, I'm from UW-Madison. It's an excellent school for actuarial science, among other things. But I'd encourage any of you who are interested in actuarial science to apply there, even though it's in Wisconsin. And you might be only looking at schools in, say, Massachusetts or New England. It is a very good school, and it's competitively priced and competitive with several of the schools in Massachusetts. So keep that in mind. As said, this was prepared by UW-Madison's Actuarial Science Department, so there's this slide saying all the things that our business department, our school of business has to offer. Regardless of your major, you still want to find things like having an active student club in your major. That's very important if your school has one. Get involved with it, whatever your major is, whatever school it is. Attend career fairs, attend employer presentations. I actually met my supervisor because he presented at UW-Madison. And I applied to work at his company a few weeks later and then was hired, actually. So going to events relative to your major is important. Going to job fairs is important. Connecting with industry, whatever industry you're in, looking to go in, that's always really important. And then the path, again, this can be brought into whatever career path you're going into. Having a paid summer internship is really important. That shows that you can do work, you can work professionally in the industry. A lot of the work that many of my classmates are doing is meaningful professional work. They aren't just reading reports or like double checking, crunching numbers. They're doing meaningful work and research in their company. Beginning the credentialing process, again, to other industries, if you're interested in engineering, nursing, things like that, veterinary science, you can begin your credentialing process while you're an undergraduate. In accounting and other CPA exams, similar to actuarial exams, if you can start taking those as an undergraduate, you can prepare yourself better for a career. There are 5 actuarial exams that a person has to take in order to become what's known as an associate in the Society of Actuaries. And taking those exams while you're a student really helps someone prepare for a career because they're taking fewer exams while they're working. It shows employers that they're more prepared, more ready to work, as well as there tends to be a pay increase with each exam passed. And that will help you find a 4-year degree. After you finish your 4-year degree, that'll help you find a job right after college. In general, actuaries tend to have 4-year degrees in mathematics, business, or actuarial science. That's not a requirement. There are plenty of actuaries coming from other majors, other areas of study, but for the most part, most actuaries have 4-year degrees. And then, as someone goes further into the actuary profession, they'll finish the credentialing process as they're working. All right, so does anyone have any questions about anything so far right now? And if not, we can go into some of the math questions, and then after that, we can take more questions at the end. So, all right, and before we do that, actually, there's this last slide about some resources. Beanactuary.com is actually a reference that one of my high school teachers showed me about working as an actuary. And through there, I found out about a few different schools to apply to and different things to help prepare for it. The first actuarial exam is called Exam 1, or Exam Probability. And I downloaded the course manual for that, and it's basically just a nice packet of 300, 400 probability problems. And I started working through that my junior year of college, and then I ended up getting a job in a different field. And then when I decided to go back to being an actuary, I continued working through the rest of it as I was preparing for that first exam. The Society of Actuaries website is just SOA.org. They're the governing body for actuaries in the US. They tend to mostly focus on life and health because the Casualty Actuarial Society, which is casact.org, is the governing body for property and casualty actuaries. So someone who gets a credential through the Casualty Actuarial Society, they'll have the credential ACAS, which is an actuary of, or an associate of the Casualty Actuarial Society, and then FCAS, which is a fellow of the Casualty Actuarial Society. And then actuarialfoundation.org is just another reference for actuaries in the US. If you would like to reach out directly to the business professor from UW-Madison, Kirk Peter at wisc.edu, he's very open, he's a great professor, Yeah, he was the professor I had for my first actuarial class at UW-Madison. Feel free to reach out to him. If you do, just let him know that you saw this presentation at Monty Tech, so he knows who you are. And if you're interested in applying to UW-Madison, just shoot him an email saying, hey, I'm currently a student in high school. Some point down the road, I'm looking to apply. He'll be really excited because a lot of our students come from Wisconsin, Minnesota, Iowa, and Illinois. We don't get very many people from New England, so he'll be happy about that. And then this is a business school's actuarial science risk management and insurance department. So within the School of Business, which is several thousand students, there's a specific department for actuarial science, risk management, and insurance. They tend to work in conjunction. There are two majors within that, actuarial science and risk management and insurance. If you aren't interested in actuarial science, but you're interested in working in the insurance and risk management industries, RMI might be a good major for you. It is less quantitative. The math skills are not nearly as stressed, but the business skills are stressed more. But it's a good major. And then the Actuarial Club, which is open to all students at UW-Madison. There are a lot of students from mathematics, from statistics, from economics, who can benefit from some of the skills that they learn in actuarial science, but aren't necessarily majoring in those. So those are just some more resources. That's the end of the presentation, so let's get into some math. This question is fairly common in actuarial science. If you have a group of people in a room, how many people do you need so that there's more than a 50% probability, or 1 to 2 probability, that 2 of them share the same birthday? Does anyone have any guesses, any thoughts? No pressure if you're wrong, just shout anything out. Go for it.
Would it be D?
Okay. And why do you think that?
Because that's like roughly half of
Okay. Yeah, that's a good thought. Okay. Anyone else? All right. Do you want to switch over to the the whiteboard mode? Let's solve this. Okay. So, okay, should I move this over? Okay. All right. So we're gonna get into some notation. This is something you'll see across areas of mathematics, not just actuarial science. So this is the probability of event A. It's written as P, A in parentheses. It's equal to the outcomes in which A is fulfilled over the outcomes in which omega, which is the total outcomes, is fulfilled. So the total outcomes is just the number of possible outcomes. And this is under the assumption that all outcomes are equally likely and independent. So if you go to a twin convention, it's more likely that 2 of the people will share the same birthday because they're likely to be twins. So the first assumption we're going to make is that everyone has the same birthday. I ran into this problem last class because there was someone who was actually born on February 29th. So we're going to assume that no one's born on February 29th and all other 365 days are equally likely and independent. So we're going to do what's known as taking a complement. So finding the likelihood of something not happening to find the probability that it is happening, because all probabilities have to add together to 1. So this is written as 1 minus probability B is equal to probability B complement. This is said as the probability of B complement. So that this little c here just means it's a complement. So what's the probability that you have 2 people not born on the same day? Any guesses? So 2 people at random, what's the probability they're born on 2 different days? You said 99%. Why? That's close. That's very close. Where are you getting that from?
Because like
So I'm getting the sense that you think, well, that's really unlikely, but it's not a guarantee. So it's like,
Exactly,
so it's nearly, but not quite. So it's actually 364 over 365. What was that? Yeah. It depends on where you're at now. So what's the probability that 3 people all are born on 3 different days? Close.
363.
Yes, yes. So 365. And then next question, you already answered, what's the probability of 4 people on different days? Yep. So then this pattern continues, and then you get what's known as 365 minus n divided by 365. So you get the pattern for the bottom, which is it's always going to be 365. And then the pattern for the top is 364 times 363 times 362, and so on, until you get 365 minus n. All over, how many 365s are there going to be if we do it this way? Yes. So there's going to be 365 to the n. So this is the probability of n people with unique birthdays. So then the probability of there being 2 people with the same birthday is just 1 minus this. So then we have, what was that?
What do you do on a leap year?
So you came in just after we said this. So this isn't a realistic model because there are more people likely to be born on Monday than there are on Sunday. So there's plenty of other things going on. Yeah, because when you think about it, if a woman's having a induced birth or a cesarean, she's more likely to do it on a weekday than on a weekend. So like there are things going on, and there are more people born in the fall than there are born in the summer, things like that. So because of that, you end up with certain other things we really can't control for. So in this unique model, we're getting rid of February 29th, and everyone has the same probability of being born on each day. So I appreciate that. That's something in the real world an actuary would have to consider. Like, what about leap year? What about the fact that November has more births in it than July? Things like that. So then we take 1 minus this probability, and then this is our probability today. Our probability of 2 people sharing the same birthday. So now that you see this formula, what value of n do you think will make this probability of A greater than 1/2? And this is pretty much at this point just a guess, unless you're very, very good at doing multiplication in your head. You don't know what 365 to the n is?
Those are your choices, I guess.
So does anyone still think it's D? Okay. Show of hands, anyone think it's C? All right, go 1. Show of hands, anyone think it's B, 23? Okay, so we got 1 for that. Show of hands for A. All right, okay, so it's actually B, 23.
See, I was right. All do it wrong.
Yeah, there you go. Yeah, this explains it. You end up with this formula. They end up using factorial notation, which is, have you seen that before?
Yeah.
Great. Yeah. So it's basically a way of multiplying consecutive integers together. So this is all the numbers multiplied from 1 to 365 divided by all the numbers from 365 minus n. So you're just left with that. And 365 minus n to 365, all the numbers multiplied in that range. So, yeah, so let's go to the next question. This one is a little bit more of a thought. Is that our time? Okay, great. So in this question, Mrs. Smith has 2 children. You already know that one of them is a girl. What's the probability that the other child is a son? What was that?
1/2.
Okay, and why is that?
Well, because it's boy or girl.
Yeah, there you go. Like that's the
Well,
like that's the thinking that you should have going into that. But then you realize there's a constraint, and that one of the children was a girl. So we go into that. But I had a student that I knew, and his roommate really hated probability because he was doing his probability homework once, and he's like, "Isn't everything a 50% chance because it either happens or it doesn't?" And my friend had to be like, "No, like when you roll a die, it's not like your probability of getting a 6 is 1 out of 6 because there's 6 outcomes. You have to like keep in mind all the outcomes." But I thought it was funny that there was like, yeah, I really like the thought of everything has a 50% chance it either does or it doesn't.
Would it be like a third? Because isn't it like when someone has like a girl, they're more likely to have a girl?
So that's taking actual biological science into an actuarial problem again, like what about leap day? What about February 29th? Like, what you're saying is true that if an individual has, like if a couple has children, having a first child be a daughter makes it slightly more likely for the second child to be a daughter. Having a first child be a son makes it slightly more likely for the second child to be a son. We aren't going to worry about that right now, but we are going to go back to the whiteboard mode and look into this one. So, all right, so then let's define probability of A as, so we're looking for a child to be a son, and we know that we have 1 daughter. So we'll again write this out as number of outcomes, there's an A over our omega set. And if I didn't mention this, the omega set is the total number of possible outcomes in an equally likely scenario. You just take the number of outcomes that we look for, divide that by the outcomes that we are constrained to. So then we're going to do what's known as writing out our set. So we're going to use set notation for this. Are you familiar with set notation? Okay. So you have a set which is designated by the squiggly brackets. You can have things in the set. They can be numbers, they can be words, they can be pretty much anything. We're just going to have ordered pairs, which is like a coordinate system. So we're just going to have the sex of the first child and the sex of the second child. So one outcome is having a female child be the first one, and a male child be the second one. So can anyone think of any other sets that would fulfill our omega? Female. Sure. Anyone else? Anyone can think of any other sets? Male, female?
Yeah, but the first one's a female.
What's the difference between these two? Yes, the order matters. So here order matters. Anyone else think of any other ones?
Well, male.
Okay.
But, no.
Yeah, so, yep, so the process went out. That's not allowed. So,
And what if the third one we were not do because if the first one was a female? Oh,
Just so that she already has a thought.
yeah, so, yeah. So, we know that she has a daughter, and we want the probability that she has a son. So, this one and this one include sons. They have the daughter here. This one does not include a son, so it's in omega, but it's not in A. So this puts it at 2/3. I think that's the question we're trying to answer is, given that she has a daughter, what's the probability that she'll have a son? I think I did that one right. I might have, yeah. Yep, yeah, that's 2/3. All right. So that's the end of the presentation. Anyone have any questions about either the questions we did, careers in actuarial science, anything like that? Sure.
So how did you find out about your college? You mentioned
Oh,
how
yeah.
you were like
Okay.
getting into it, but
Yeah, sure.
how
So,
did you choose it over others?
yeah, sure. And just so I don't run over and give time to other questions, what time should I be done by?
We get out at 10:40.
10:40, so I have quite a bit of time, okay.
Yeah.
So, and if I finished, is there anything you want to do, or if there ends up being extra time, could we go over the Pascal's triangle again?
Oh, sure.
Yeah, cool, all right. So at the end of the last class, we had a interesting question about Pascal's triangle, so I went over some of the things with that. So the long story is I went to University of Massachusetts Lowell, had a bachelor's degree in mathematics and chemical engineering, worked for a software company known as Epic Systems in Madison, Wisconsin. They're a medical records company, so they take hospitals and they sell them the service of providing what's known as an EMR. EMR stands for electronic medical record, whereas a one place where they can aggregate all of their medical records instead of having just pages upon pages of medical records in charts in their basement. It takes up a whole bunch of space. The security on it is really elaborate, whereas you can just have electronic security where you have like a two-factor authentication, things like that, where it saves a whole bunch of infrastructure in the hospital and it saves on a whole bunch of vulnerabilities, like say hospital gets broken into, or say someone's access card gets lost, then you have an access card roaming around, or someone can break into your hospital. So because of that, around 1980, electronic medical records started becoming more popular. They started being used, became an industry standard as part of the Affordable Care Act. So I worked there for a while, and then I had this like printout of all of the exam questions for exam P. There's over 300 from the Society of Actuaries. I had that, and occasionally I flip through it and be like, oh, like some of them are I find interesting, but are like pretty mundane about like, so you have, there's a lot of questions about pulling balls out of urns. Like you have colored balls and finding the probability of them, and then like rolling dice, what's the probability of rolling a 7, a 3, and then either an 8 or a 5. And you can do similar things with probability to that we did earlier to determine those probabilities. And I was like, this work is more interesting than some of the stuff I'm doing at work. So eventually, I started studying more and more for exam P, realized that exam P is exam 1 or probability. It's just called exam P a lot of the time. But yeah, I ended up spending a lot of time studying for exams, and I was like, well, it's really not possible to continue working in order to prepare as much as I'd like to. So I was living in Madison, Wisconsin at the time. I was like, well, maybe going to school for this instead of just trying to keep it on the side might be a really good way to get my foot in the door. Because I had a friend who was an actuary, and she had a colleague who'd gone through the same program that I'm in, which is a graduate certificate in actuarial science. So that's how I came across it. It was mentioned by a friend, and I applied for it in the summer of 2016 and started in the fall of 2016. So that's how I came across it. It happens to be one of the centers of excellence for actuarial science, which are organizations like the Society of Actuaries and Casualty Actuary Society, which designates certain universities and colleges across the US and Canada as centers for excellence in actuarial science, which means they're hubs for actuarial science, and they're universities or colleges that can prepare someone for a career very effectively. That being said, there are plenty of great schools for actuarial science that are not CAEs or centers of excellence in actuarial science. But yeah, that's how I came across it. Anything else? Sure.
Do you know of any good like actuarial schools near here?
Okay, yeah, so St. John's University is in New York, which I understand is not most near here. But WPI, I believe, in Northeastern are places I looked at, and I believe they both have actuarial programs. I could be mistaken. When I was looking for actuarial programs, I was looking for them in conjunction with industrial engineering programs, which are related in terms of your skill set. An industrial engineer does a lot of the same optimization that an actuary does. So I was considering those two together in terms of my career search. I eventually ended up choosing chemical engineering at UMass Lowell because I had the most amount of incoming credits for it, and I had a chance to interview one of the professors in that department. It was one of the few departments that when I visited, a professor just gave me her contact information and said, just give me an email, I'd like to learn more about you. I think that you'd be a good fit for our program. And just personal touches like that really go a long way. I ended up doing research for her when I was a junior in college. So that was a good fit for me, but it ended up not being what I wanted to do long term. All right. Anyone else have any other questions?
Thank you very much.
All